With chapter 8 and dealing with introduction to functions, points, lines, and their graphs. So to graph ordered pairs in linear equations, I love how they say in with two variables. In two variables, that's weird. Plot a point. A point is a solution of an equation. It's an ordered pair. Horizontal axis, horizontal number line, in a number plane, the x-axis. Yep. The origin is the center, 0, 0, where the axes intersect. Vertical axis is a sort of like a thermometer. It's the y-axis. The graph of an ordered pair, that's plotting it on a coordinate plane. Abscissa, I've never heard of that word. The first coordinate in an ordered pair of a number. The x-coordinate. Oh, the abscissa, the abscissa, and the ordinate. I guess I should know those. That's the y-coordinate. Coordinates of a point, that's the abscissa, and the ordinate of the point written as an ordered pair. Coordinate axis, x and y axis. Coordinate plane is the whole thing. Quadrant, you have 4 quadrants. The intersection of x and y create 4 quadrants. Graph of an equation with 2 variables. That's called a linear equation. Standard form is ax plus by equals c. So the x and the y are on the left side and your constant is on the right. Something important, here we go, about standard form. And we can talk about this because you have ax plus by equals c. And a, b, and c must be integers, positive or negative or whole numbers and their opposites, where they're integers, and a must be positive. I've seen that, must be positive. So a, b, and c cannot be decimals or fractions. It doesn't say it here where a is positive, but you find that that is the case in many books. Apparently not in this book, but that's just a little thing. So plot each point. We're going to plot the point A. This is the x value. This is the y value. This is where you're going to go on the x-axis. This is my x-axis. So I'm going to go -1, -2, -3 on the x-axis, and then I'm going to go my y. I'm going to go up 2 on my y. So that's how we find those locations for each of the points. So we're going to take A. I'm going to try to do different colors. This will be hard. We'll probably run out of colors real quick. So 4 on the x, 1, 2, 3, 4 on the x, 2 on the y. That's up 2. So that is going to be where my A value is. That's A. I guess I should do it in pen. Let's do it in pen. So 1, 2, 3, 4, 1, 2. That is my A value. Let's pick another color. Let's do B is 6 on the x. 1, 2, 3, 4, 5, 6 on the x. 1, 2, 3 on the y. So that's my B value. Right next to each other. That's not very nice. C, -4 in the x. So -1, -2, -3, -4, and then -2 on the y. So that takes me to here. And that's going to be my C. Let's do D, -5. 1, 2, 3, 4, 5. -1 is here. Again, way to put it right next to the 2. E is -5 on the x and 0 on the y. So that is going to be E. We don't move anywhere off of the x-axis. This is the x-axis. This is the y-axis. Let's do, oh, that's a nice color. Skin tone. 0 on the x, so we're not going to move off of the y-axis. Then we're going to go down 1, 2, 3, 4, 5. So that is going to be F. It's my F value. And that's a good steel color. G is -3. 1, 2, 3. +2 is G. And last color, oh, purple. 3 on the x, 1, 2, 3, negative 2 on the y takes us to that, and that is going to be my h value. So those are the points and their locations. Now this is a fun one. Now we can do highlighter. So the point on the positive x-axis. So this is my x-axis. This is the positive side. So that would be z. Let's change the color. The point on the negative y-axis. So y-axis is the vertical. Negative would be that point. The points on the vertical line through z. Vertical line through z would be A and P. So those are the 2 points on a vertical. Vertical is up and down. Let's do this color. That's an interesting color. The points on the horizontal line through y. Horizontal through y. Oh, through y. Oh, that's going to be both these. So we see A again. Let's do pink. The x-coordinate is 0. So what has an x-coordinate of 0 is going to be G and Y. That didn't do a very good job of showing up G. G and Y has an X. Let's look at that lovely green right there. That might be too close to the other green. Let's do steel again. The Y, whoa! The Y coordinate is 0, so Y, so that would be Z and V. No, we haven't done a red. Let's do a red. The points have equal X and Y coordinates, so their X and Y are the same. So this is 4, 4 right here, because we're in increments of 2. So that's 4, 4. H would not, because that would be 4, negative 4. B would be negative 6, negative 6. So that would be okay. I think that's, yeah, 2, 4, 6. Yep. So it would be just D and B. Oh, and C. Don't forget. Oh, and A. Because A is 6 and 6. C is negative 2 and negative 2. B is negative 6 and negative 6. All right. Almost got caught there. Let's do orange. 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 The points have opposite. No, that's too close to my red. Let's do that. No, that's already done. I know now it's hard finding colors. Let's find a color. Let's do super hard purple. I don't know if we've done a hard purple. I did it again. Why won't you? Yeah. Oh, yeah. That's a dark purple. X and Y have opposite. So that would be 1, 2, 3, 1, 2, 1, 2, 3. So P would do it. H would also. J would have opposite. That's negative, negative, positive. And it would be along that axis. Yeah. All right. Those are the ones. Cool. I guess I should have listed them. So we'll go through them again. Point on the positive axis. That would be Z. Negative axis would be G. Points on the vertical line Z. A, Z, and P. Points on the horizontal through Y is K, Y, and A. X coordinate 0, that would be Y and G. Y coordinate is 0, that would be V and Z. Points have equal X and Y, that would be B, C, D, and A. Opposite coordinates are going to be J, H, and P. That was fast. That was okay. That was graph in a coordinate plane. Let y equal 0. Let x equal 0. So we're plugging in and we're finding the intercepts, and then find a third solution so you can plug in any other x value. So we're going to plug in the intercepts. So we're going to plug in when x equals 0, so 0 minus y equals 4, negative y equals 4. Let's divide by negative 1. We get y equals negative 4. So when we plugged in 0 for x, we get negative 4 for y. Let's plug in 0 for y. So we have x minus 0 equals 4, and that's x equals 4. So when x is 4, y is 0. Those are 2 points. And then let's find a third one because they wanted a third one. So we can pick either an x or a y value. I'll pick an easy one, x of 1. So we get 1 minus y equals 4. Let's move over. Negative y equals 3. Let's divide by negative 1. We get y equals negative 3. So the coordinate is going to be 1, negative 3. These 3 points should align. 0, negative 4, 1, 2, 3, 1, 2, 3, 4. That's 0, negative 4. We have 4, 0, 1, 2, 3, 4. That is 4, 0. And then I found the point 1, negative 3. 1, negative 3 was here. 1, negative 3. Do we have to graph it? Yes, we're going to graph. We're going to connect that line. Whoop. Hey, that's not bad. Whenever we graph, we want to put arrows on our lines to show that the solutions go till forever. Oh, that's not going to work. And that was 4, 0. 4, 4, 0. I just like to have my points legible. Again, let's plug in x equals 0. We get 0 plus y equals 5. Y equals 5, so that coordinate is 0 for x, then 5 for y. Let's plug in 0 for y. We get x plus 0 equals 5. We get x equals 5, so the point 5, 0. And now let's pick another number, like x equaling 1. So 1 plus y equals 5. Let's subtract 1. We get y equals 4. So when x equals 1, y equals 4. Let's plot those 3 points. 0, 5, 1, 2, 3, 4, 5. 5, 0, 1, 2, 3, 4, 5, 0. And then I had 1, 4. 1, 4. So that is 0, 5. 1, 4. 5, 0. Connect the dots. Make sure that they go over my dots. And let's put arrows on the end of that. Those are all the solutions to that equation. That's the cool thing about this, is we can find all the solutions to these equations. Is 0 plus 6, y equals 6, so that point is 0, 6. Let's plug in 0 for y. 0 equals 2x plus 6. Solve for x now. Negative 6 equals 2x. Divide by 2. Negative 3 equals x. So when x is negative 3, y is 0. Let's pick another value. Sorry, don't need to extend that. Let's pick when x equals 1. So we get y equals 2 times 1 plus 6. Y equals 2 plus 6, y equals 8. So when x is 1, y is 8. So our intercepts, we have 0, 6, 1, 2, 3, no, 0, 1, 2, 3, 4, 5, 6, the y-intercept. Negative 3, 0, this is the x-intercept. And this point, 1, 8, should lie on this line. 1, 8 is going to be right here. Does that continue in that? If I extended those 2 points, yeah, it does. It should continue along that linear formation. Hence why it's called a linear equation. This is negative 3, 0. We always want to label our points. It is very beneficial to label our points correctly. This is the proper way to label a graph. Let's plug in x is 0. We get y equals negative 2 times 0 plus 2. Y equals 0 plus 2. Y equals 2. My point is 0, 2. plug in y equals 0. We get 0 equals -2. Just wanted to move this over a little bit. Y equals -2, x plus 2, subtract 2, you get -2 equals -2x, divide by -2, 1 equals x, and we get the point 1 x when x is 1, y is 0, and let's plug in 1. So y, oh no, we can't plug in x is 1. We already have that right there, so that would have been redundant. So we have to plug in x is 2. Y equals -2 times 2 plus 2, which gives us y equals -4 plus 2, or y equals -2. When x is 2, y is -2. We have 3 points. 0, 2, that's my y-intercept because it's on the y-axis. 1, 0 is my x-axis because it's on the my x-intercept because it lies on the x-axis. It's where it crosses, it intercepts the x-axis. And then we have 2, -2. 2, -2. Yeah, it doesn't look just because I drew my middle point a little kittywampus, but that works. This is 0, 2. This is 1, 0. This is 2, -2. Label those coordinates with parentheses, please. I'm going to put in slope-intercept form because it's going to be easier to solve when x equals 0, y equals -2 times 0 plus 4. Y will equal 4, so we have the coordinate 0, 4. Y equals 0, 0 equals -2x plus 4 minus 4. -4 equals -2x, divided by -2. 2 equals x. We have the coordinate 2, 0. And let's plug in x. This time we can plug in x equals 1. Y equals -2 times 1 plus 4. Y equals -2 plus 4. Y equals 2. So 1, 2 would be my third point. Let's graph 0, 4. That's my y-intercept. 2, 0 is my x-intercept. And my third point, 1, 2. And yes, that looks pretty good. Those are the points. Connecting the dots. Labeling my points. 2, 0, 1, 2, 0, 4. Nice. And that's all we're doing. We're going to solve for y. We get -3y equals -x plus 6. Divide everything by -3. A little technical here. That's going to give me positive 1/3. Two negatives make a positive. X. And positive 6 divided by 3 is -2. I'm going to find my x is 0. That's going to give me y equals -2. So the coordinate 0, -2. When I plug in 0 for y, that's going to give me 0 equals 1/3 x minus 2. We're going to add 2. 2 equals 1/3 x. Multiply both sides by 3. The inverse of multiplying by 1/3 is multiplying by 3. 6 equals x. So we get 6, 0. And now I'm not going to pick 1. So my x value, if I pick x equals 1, it's going to give me a fractional. I want to get rid of that fraction, so I'm going to multiply when x equals 3, because y equals 1/3 times 3 gets rid of that fraction. So y equals 1 minus 2, y equals -1. So I like having whole numbers for my coordinates, so I'm going to I'm going to pick wisely. I'm going to choose wisely when I pick numbers to plug in for my third point. 0, -2 is here. 6, 0 is out here. And then my other point is 3, -1. 1, 2, 3, -1. And yep, that lies where I was expecting that point. It still adheres to the line. It lies on the line. All solutions should continue on that line. So we have 0, -2. We have 3, -1. And we have 6, 0. Nice. Minus 2x minus 2x, negative 3y equals negative 2x plus 6. Divide by negative 3, divide by negative 3, divide by negative 3. Is this the same problem? No. Very similar though. Y equals positive 2/3 x minus 2. So let's plug 0 in for x. We get y equals negative 2. So that is 0, negative 2. Let's plug in 0. Sorry, moved the wrong one. Plug in 0 for y. We get 0 equals 2/3 x minus 2. Add 2. 2 equals 2/3 x. Multiply by 3/2. Multiply by 3/2. The 2's cancel. Denominator, numerator. So we get 3 equals x. So that point is 3, 0. And let's pick and choose. Let's go 3 again. So let's choose x equals 3 because we get y equals 2/3 times 3 minus 2. We get y equals, oh, Mr. Mac, we can't. X equals 3. We already see what happens where x equals 3. So we can't pick 3. Let's pick 6. It's a multiple of 3, so we get, these cancel, you get 4 minus 2, y equals 2. So my other point is going to be 6, 2. Be careful, that's a good learning experience right there. 0, negative 2. 3, 0, yes, we know 3, 0. And then 6, 2. 6, 2 goes right there. Connect those lines. We are looking good. Yep, boom, boom, 0, negative 2, 3, 0, 6, 2. Last one. I feel like I've seen this problem before. Negative 2x, negative 2x. 3y equals negative 2x plus 6. Divide by 3, divide by 3, divide by 3. Y equals negative 2/3 x plus 2. Plug in 0 for x. You get 2 for y. That's my first point. Plug in 0 for y. Y equals 0 gives me 0 equals negative 2/3 x plus 2 minus 2. We're solving for x. Oop. Let's multiply by negative 3/2. That's the reciprocal of negative 2/3. That gives me positive 3. So we have 3, 0. Now, again, I have this. I need to find a third point. I'm not going to pick 3 because I've already had it. So I'm going to pick 6 again. And we get y equals negative 2/3 times 6 plus 2. You get negative 4 plus 2, negative 2, so 6, negative 2. We have 3 points, 0, 2, 3, 0, and this time it is 6, negative 2. So 6, negative 2. Oh, that was nice. Split those hairs, baby. This is 0, 2. This is 3, 0. This is 6, negative 2. Voila! All right. That's a good one. It's good practice. Solving, graphing, plugging in values to find. That's always your safeguard. It's the easiest way to graph a line is by plugging in points. You want to plug in easy values. X equaling 0 is always your easiest value to plug in to find a point. And then you want to see if it's a fractional coefficient like it is. We have a fraction as the coefficient of x. We have to be careful about what we plug in. We plug in 1, we're going to get negative 2/3. And then negative 2/3 plus 2, that's 1 1/3. Who wants to graph 1 1/3 on a graph? No, we like whole numbers. So we're going to tend to choose points and values that produce whole numbers. So good luck.